Hello, this is Matthew Luke, and today I'm going to be presenting my co-op experience this past spring. This was my first co-op rotation, and I was working at ATI Industrial Automation. My job title at ATI was as a mechanical engineering co-op. This first rotation, I was in the product engineering department, supervised by Stephanie Jeffers. I've since completed another rotation this past fall where I was with Richard Hevner in the application engineering department. And for my third rotation, I'll be finishing off as a project engineer in the electromechanical and electrical module department, supervised by William Barakal. That'll take place next summer, but today I'm going to be focusing on my rotation with product engineering. I'm going to start by going through some of the major projects and other responsibilities that I had during my rotation. One project that I would consider to be one of the most influential was changes to some of the design standards at ATI. So they have what's called electrical modules, an example of which you can see on the right side of the screen. Some of those are a little bit smaller, like the picture on the left. That kind of bluish piece there is what's called an R-style module. So that's for smaller electrical signal and electrical power pass-through through two sides of a coupling tool changer, which is one of the main products that ATI manufactures and designs. So this part has a series of GD&T datums that help to define how it's made and whether or not it passes an initial inspection. There have been some problems with parts coming in and being compared to the drawing and coming up as passing or not passing inspection. They should actually be kind of reversed, and this is due to how the datum precedence is set up. So basically, what face or hole or other feature is kind of the initial anchor point. So for example, the dowel holes in the middle, down on the lower right side, those can come in out of tolerance and throw off the large hole on the front face, which is a receptacle for an electrical connector. So this project involved kind of a deep dive into GD&T and some work with the metrology department to showcase why the current process doesn't work as well as it should, and how the datum precedence should be changed so that it can do a better job. And what's pictured here is kind of just a 3D printed model of a jig I made and then that R-style module to show how they fit together. And it's actually has been printed and used by someone in the metrology department to show the need for the change. So another project I got to work on that I enjoyed was a little bit of part design. So they had some issues with these electrical modules colliding, and the kind of sensitive areas where the electrical pins are held would come into contact, and with too much force they would fracture or move. So they needed some sort of device to catch kind of the blow when the two sides of the tool changer are coupled. And the robot presses the master and the tool together. And that's what this little bump stop does. So that was a lot of fun for me. I got to do quite a bit of work in SolidWorks and look at old test reports, things like that, and go through a variety of drawing reviews and design reviews with engineers there and figure out how best to define my parts so that the critical tolerances and geometries were always correct. Another project I worked on during my rotation was a custom interface plate for a specific customer, which kind of helped lead into my second rotation as an applications engineer, who's someone who interfaces with customers on a daily basis. But in the product engineering group, there was a product request that came through for a custom interface plate, which is that kind of grayed out object on the side of the model pictured below on the left. And that interface plate currently has a very large stack height, to account for the fittings and hoses that run through the wrist of that robot to supply air and paint through the pictured tool changer. And the customer needed to see whatever the smallest stack height could be on the whole assembly. So this project didn't really have any kind of clear bounds other than it being the smallest that it could be. So I had to do some research into different types of fittings, different bend radii, and talk to some of the engineers at ATI and actually some of the engineers that the customer employed. So I thought that was pretty interesting to sit kind of in a meeting with people from ATI and from the customer at the same time, try to understand the problem and work through issues. Thought it was a pretty rewarding experience for a co-op. Kind of doing these custom projects and supporting customers in a variety of ways is one of the ways a smaller company like ATI has really gained ground in the industry. And I thought it was great to get to be part of that a little bit. Another big part of my responsibility list was GD&T markups for engineering change orders. So here on the right is a pretty involved markup that I got to work on. This one was kind of as messy as it got. And I thought that was pretty interesting because I didn't know much about GD&T before my co-op rotation. So getting to take kind of this dive into it, I got to learn a lot. So this piece allows you to attach a couple of those electrical modules to the edge of one of the tool changers. And this design was old. I needed an update for the tolerancing in order to continue being machined at the current price or even at a price reduction in some cases. So this was part of an effort to standardize a lot of the older drawings so that everything included GD&T. The last major responsibility that I got to be a part of for this co-op rotation was looking at non-conforming material requests, also known as NCMRs. So these are parts that come in from suppliers that don't meet the tolerances or the measurements that are on the print. So one of the main roles of the product engineering group in the NCMR process is to determine whether or not these out-of-spec parts are still useful or not. So this was one of the ones that I thought was a little bit more fun because I got to do some CAD modeling seen on the right. So the channel in this module, the kind of inner diameter was out of position relative to the center line and therefore like the outer diameter. So I kind of modeled the picture on the right to represent the channel there that can be seen in the cutaway view, and then the valve seal that goes into that. So I did this to provide an easy way to see whether or not the part would accept the valve or not. So through this, I got to go and look at a variety of parts, calculate like tolerance stack ups, and kind of really understand where the particular like GD&T requirements come from, and then why some tolerances are held much tighter than others, and what parts of this module are critical for the product to function properly. So that's something that I thought was really interesting, was actually going through like machine parts, figuring out, just because maybe the overall length of this part is a little bit off, maybe that's still a usable part if the actual port is still where it needs to be relative to a specific feature like an edge or like a dowel hole or something like that. So this process allowed me to get a better understanding of why GD&T and tolerancing are important. Throughout my rotation, I had different projects that had a variety of impacts on ATI. Making changes to the design standards helps make the inspection process better. and allows you to process more parts that are still usable, even though they may be out of tolerance, and making sure that the inspection process accurately captures what's different about parts. Getting to do some part design, I hope to create a better product, something that's more reliable for customers, less likely to break, which results in happier customers. Getting to work on some custom projects, I think that I made an impact by bettering a customer relationship. I got to work directly with a customer and help them see what they needed to see and get the solution that they required. With the GD&T markups, helped us standardize old drawings, which was a benefit for ATI because they needed to update a lot of that, and that will help them decrease some of the costs associated with making these parts and the machining. And kind of in a similar area, getting to work on the NCMRs, I helped to decrease scrap waste by proving that parts that were slightly out of tolerance could still be used, and even some parts that had tight tolerances could be relaxed in some cases, which again kind of helps decrease machining costs. In doing this co-op, I got to see the variety of different products and roles that are in the robotics industry, specifically like working with industrial robots. Just learning that there's somebody that makes the robot, somebody that makes the tool changer, somebody that makes the car, and then even somebody that creates like the assembly line that the car goes down. I thought it was really interesting to see how all the different pieces of the puzzle work together to, in the end, create like a functioning car manufacturing line or something similar. I'm also getting to hear a little bit about the challenges of expanding into new markets or into new businesses. People think that automation is really challenging or really expensive, and in some cases it can really help out and help people. Also looking at working for like a small company versus a large company. At a previous internship at a large pharmaceutical company, so getting to kind of compare that to this rotation with a small company, I got to figure out that I enjoy getting to work at a small company, seeing the people that make the decisions that impact your daily life is something that I think is really cool, and you get to feel like you're really contributing to a place that you work. Also, just kind of the different variations in what someone with a mechanical engineering degree can do based on kind of their interests. I think that's something that gets talked about a lot in school, but for me, it wasn't something that was necessarily fully understood or even understood as it is now until I had my rotation and I got to work with different people in the industry and see all the different things that engineers can do at a company. Through this rotation, I feel that I really strengthened my communication skills and some of my interpersonal skills. Just working with other engineers, having to present things to my boss, and speaking with people in a professional environment every day. I also gained confidence in some subjects of engineering that I haven't had a ton of experience in, like part design or like CAD modeling and tolerancing. Another thing that I think was pretty important was kind of the realization that not all these real life problems have a super clear or definite solution. Not everything's as easy as plugging numbers kind of into equations and figuring out one correct answer. There are times where you need to assess different solutions to a problem and then choose what you believe is the best solution. And I think most importantly, this rotation helped me to confirm my plans to become an engineer in the future and helped reassure that I'm on the right path for myself. Well, that's the end of my presentation on my work with the product engineering team at ATI. Thanks for listening.